Hello, this is Oleksandra presenting the research done at ISIR at Sorbonne Université under the supervision of Gilles and Baptiste Caramiaux. Decision-making is an integral part of our lives, but some decisions can be difficult to make. Artificial intelligence, or AI embedded systems, can assist humans in making decisions that sometimes can have high social impact. For example, deciding which candidate to choose, or assigning a loan to somebody, or predicting cancer grade. In these cases, a wrong decision can potentially lead to big negative consequences. Building a collaborative relationship between human deciders and AI-embedded systems is therefore a challenge and mostly relies on trust from users towards the systems. In this article, we understand trust as an attitude that an agent will achieve an individual's goal in a situation characterized by vulnerability and uncertainty. And we're interested in various aspects of trust: its development, formation, loss, and recovery. Trust remains a highly challenging theoretical concept to study due to its multifaceted and multidisciplinary nature. While there are guidelines that support design of trustworthy AI, there are yet to be guidelines that support empirical study of trust in AI-embedded systems. In this article, we're focusing on how to assess trust between human users and AI-embedded systems in the context of decision-making. Therefore, we're interested in the following questions. What is trust? How to evaluate it? How to measure it? To tackle these questions, we conducted a systematic review of experimental methodologies set to investigate human trust in AI-embedded decision-making. Here is how we did it. To identify the relevant keywords for the search string, we conducted an exploratory search. We used general terms related to empirical studies of human trust in AI while making decisions, for example, artificial intelligence, machine learning, trust decision participant. Once we had a list of the related keywords, we went through multiple iterations of their combination to finalize the search string. It resulted in 5,000 research papers, and we started out selection process. We first excluded not full papers, that is, extended abstracts, workshops, posters. Then we skinned the abstracts of the remaining papers and excluded the ones that were out of scope. That is, not related systems, theoretical papers, modelization, or no decision-making involved. This left us with 254 papers. We read these papers entirely and excluded the ones that didn't fit the scope. At last, we had our corpus, 83 papers. To be able to analyze and discuss the information present in every empirical study in a structured and a systematic way, we elaborated the following annotation themes. First, in the related work, we searched for the definitions of trust used and their origins. Then, we extracted the information corresponding to each element of an experimental protocol. In the subsection about participants, we extracted the information about their background and their number. In the subsection about task, we noted what the process of decision-making was, as well as if there were any task feedback and outcomes. In procedure and experimental design, we focused on instructions and the order of questionnaires. And lastly, from the subsections on data collection methods and analysis, we extracted types of measures used, how they were implemented, and analyzed. Once we annotated each paper based on the grid, we identified similarities in each section and grouped them. This resulted in a categorized and a complete overview of methods used for studying trust in AI-embedded systems assisting decision-making. Additionally, relying on handbooks and reviews, we informed ourselves about common practices in studying human-human trust, as well as about raised issues in methodology and proposed solutions. We therefore were able to draw parallels between human-human and human-AI trust methodology trends. Based on this comparison, we provided 16 guidelines aiming at overcoming identified methodological limitations in studying human-AI trust. We also proposed 9 research opportunities for investigating further trust factors and trust methodology in the context of AI-assisted decision-making. Here, I will highlight several major points in the findings. Definition of trust plays an important role for the experimental protocol, notably its three key elements. These key elements are attitude, the fact that trust is what people feel but not necessarily show through behaviors. This has a direct impact on how we should measure trust. As trust does not systematically translate into a behavior, the preferred methods to measure it should be self-reported measures rather than behavioral ones, such as number of times participants followed the recommendation. The behavioral measures are nevertheless trust-related, so they should be called trust-related behavioral measures rather than behavioral trust measures to prevent results misinterpretation. The second key element is positive expectations, which means users believe that the system will achieve the goal of the task. This, in turn, affects the way we should introduce the system in the instructions, as well as the first and the last users' interactions with the system. For example, if there are any wrong recommendations, they should not appear in the very beginning and the very end of the interaction to avoid a damage to trust that might not diminish over time. The last one is uncertainty and vulnerability. That is, that outcomes of a decision are uncertain and have potential negative and undesired consequences. Therefore, task outcomes play an important role in triggering participants' sense of vulnerability, making them feel that their decisions matter, that they have something at stake. If these three key elements are not integrated in the experimental protocol, the results might be related to other theoretical constructs related to trust rather than trust, such as reliance, an example of trust-related behavior, distrust, in the absence of positive expectations, confidence, in the absence of vulnerability. In conclusion, this paper achieved three things. Firstly, an exhaustive presentation of the variety and complexity of methods to study human-AI trust in the context of decision-making. Secondly, a structured discussion of human-AI trust protocols highlighting flaws in methodologies with a stronger link to the human-human trust community. And lastly, a set of guidelines and research opportunities to improve research quality in human-AI trust, highlighting the need for a greater empirical rigor in the community. Check out the paper for more details, and we would love to discuss it with you, so feel free to reach out. Thank you!